this was session 4. I believe this was fraction sense. That's right. We were just getting used to fractions. Hopefully, by now you're getting the hang of this a little bit better because you've had to add and multiply and everything else. So you were told a light green fraction strip is 3/4. This is remembering that your numerator tells you how many you have. The 4 tells you how many there would have been in the whole. It doesn't necessarily mean you're seeing the whole. Right now, 3 is how many you have. Green fraction piece is 3 out of 4. So it's just 1, 2, 3. So it's 3 out of 4. That means the whole would have been one more chunk, which would have been 4 out of 4. And if you hold these up together, the whole is going to be the purple one. The whole is exactly one. It's exactly one more piece bigger than the green. And a fourth, the pieces that you put together to make 4 for the purple were the whites, okay? A purple fraction strip is 3/2. Again, the purple represents 3 of something. So you need to break purple into 3. Now, the fact that they're halves means you have something bigger than a whole, which means 2 of these halves would be the whole. Okay, and then the question said, show what a fourth looks like. Well, the whole is just these first 2 blocks. We're going to ignore this one. So I've drawn a line there. So if this is the whole, that means this is the half, which means each of these halves cut in 2 would give me the fourth. So that's what I'm looking at. If a brown fraction circle piece is 5/3, what piece is 2/3? So again, we're starting with the brown fraction circle piece. And then it's 5/3, which means it's being cut into 5 pieces. So the only thing that made 5 was 5 purples made that. Okay? Now these are thirds, so hopefully you know that shading this in is going to be your whole. Okay, there's your whole right there. There's thirds. Or you can shade in on this side. So your whole is going to be just 3 out of 3. And then the question was, what piece is 2/3? So if the whole is 3/3, each of these pieces is 1/3. So over here, if you do 2 of them together, that's going to be 2/3. 3/3 is the whole. And the one piece that fit on top of these 2 purple pieces was 1 green. So 1 green would be the color. That would be 2/3. So again, you're starting with, you have 5 pieces into the brown. You got to cut the brown into 5 pieces, which turned out to be 5 purples. Then figure out what the whole is. That would be 3/3, which would be this much. And from there, you can figure out what 1/3 would, and then 2/3 would look like. A yellow fraction circle, I started with this, is 3/4, which means it's cut into 3 pieces, and 4/4 would be the whole. So the yellow is just 3. The numerator tells you how many pieces, so I only had 3. And 3 pinks fit perfectly, so if you add 1 more pink, you now have 4 pinks, which is the whole. The question says, what is 1/2? Well, first you have to have the whole, which 1/2 would be, since 4 pinks is the whole, then 2 pinks would be a half, and that turned out to be the same size as 1 orange. Okay, 12 counters are 2 sets of 3, which means the 12 counters are going to be cut into 2. Okay, it's not the whole, it's just 12 counters are 2. So I took 12 counters and I cut it into 2 pieces. Now it's 2 out of 3, which means you need another piece that's exactly the same size as the 2, so I added the third piece with just X's. So now we have 3 out of 3, so when you add them together, the whole is going to be 6, 12, and another 6, which is 18. Okay, so there's 18 here, and it said how many counters are half, which would be half of 18, which is 9. Okay? If you need to look at this again, stop this video at any time and stare at it and think about it. You don't have to keep going. I mean, don't force yourself to keep going and just get confused. Stop a minute and think about each of these to make sure you're clear. If 12 counters are 6/5, again, the numerator tells me how many pieces I'm going to be dividing into. So I've got 12 counters, I want to divide it into 6. Well, that goes pretty easily. 12 divided into 6 means I'm going to do it in groups of 2. So I have 6 groups of 2. This is fifths, which means 5/5 is going to be the whole. So we're only going to choose the first 5 for the whole, okay? How many counters are in the whole? Well, these first 5 groups, which comes to a total of 10. Okay, 16 counters are what fraction of a whole set of 12 counters? Now this time you're not given the fractional part. You're told that 16 is the fractional part of 12. And people always think of fractions as smaller, but in this case that's not true. 16 is not smaller than 12, but it is still a fractional part. So the first thing you need to do is draw 16 counters and then cut off 12. Okay, so here's 16 counters right here. I isolated 12, and then I tried to find a way that you're looking for, basically what you're looking for is a common multiple, because you can't really chop 16 up into 12s and get any meaningful information about it unless you're cutting it into piece sizes that work with both 12 and 16, which would be 4. If you did 3, how are you going to talk about 16 if you're doing groups of 3, because 3 doesn't go into 16 evenly? Okay, and you can't talk about 8 8 goes into 16 evenly, but it doesn't go into 12 evenly. But 4 goes into both of them evenly. So I grouped these in groups of 4, because so that way I could talk about 16 and 12. So I went ahead and cut them into groups of 4. 1, 2, 3/3 it would be the whole for 12, and then there's one more group of 4, which is 4/3, and that's why 16 counters can be taught about as 4/3. I also did it this way. I wrote out all 16, so there's 8 on the top, 8 on the bottom. Again, in this case, the every 4, again, we used 4. We used a common factor of both 16 and 12 to break them up, something that both numbers divided by. So we have 4, 4, 4, and then there was an extra 4. And if this was the whole, then there's 3 sets out of 3, which means this was another set of 3 or 4/3. Okay, those are things you need to know. Again, here's these Venn diagrams. The big thing on this one is benchmarking, being able to tell. And this one's a little hard to say. Let me pick another one. I'll go do another one in just a minute. That the benchmarking is probably a little clearer on a different problem. Make sure you know how to read this ruler. Whenever you drop down for reading a ruler, check to see how many pieces this is cut into, because that's going to be your denominator. If you count spaces, not numbers, 1, 2, 3, 4, there's 12 of them. Then you count how many you have here, which would be 7/12. You have 2 wholes before that, so it's 2 and 7/12. The fact that these aren't the same is irrelevant. It's still 2 wholes, and then the fractional part is only on the part that is just not a whole. So you don't care what size pieces these are in, because they're wholes. For this one, you have 1 whole, so you're done with that one, and then you have this piece cut into smaller pieces. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 spaces here, and you're doing 2 of them, so it's 1 whole and 2 tenths. And then finally, this one came down right here. It didn't come down in the bigger ones. There's 8 of these bigger ones. 1, 2, 3, 4, 5, 6, 7, 8. There are 16 of these little dinky ones, and that's what it hit, was a little dinky line. So it ended up being, if you count, you're up to 13 here. So 13, then these are 16ths, because there's 16 of the little bitty lines, and the little bitty lines are included in the big lines as well. All the big lines are exclusionary to just themselves, but the little bitty lines count the big lines as well as the little lines. Okay, we've got that. Oh, this is a good one to look at benchmarking, because you will have something on the test concerning benchmarking. Okay, this one, you can't use calculators cross multiplying. I want you to just use benchmark. So on this one, you should have looked at each of these and kind of got an idea of how close they were to either 1, 1/2, or 0. 10 over 11, hopefully you saw, was fairly big. It's almost 1. It's only 1 away from 1, and 11ths are not real big numbers, so it's pretty close to 1, because 11th is not very large. So it ends up being, it's going to be over here at the end somewhere. 216 over 423, 2 and 4 are half. 1 and 2 are half. Now 6 and 3 is more than half, but this is your ones. So the hundreds, you're half of 100, you have half of your 10. So this is really close to a half. So I'm going to guess it's somewhere in the middle. When I was doing this, I just kind of randomly put them in a place. Then 1/3 I know is going to definitely be less than a half. 3/10 and 1/3 look very similar. 1/3 looks at 3/10 looks like it's about a third too. You'll notice that if you multiply 1/3 by 3, you get 3/9, which is really close. 3/9 and 3/10 are almost the same, except for tenths are smaller than ninths, which means 3/10 is going to be smaller than 3/9. Remember, 3/9 came from multiplying the top and the bottom by 3 of 1/3, which means that 1/3 is bigger than 3/10. So that means 3/10 is, did I do that backwards? We're going from smallest to largest, yeah. So 3/10 will be first, because it's the smallest, and then 1/3, which is bigger. Both are smaller than a half, so you're not going to have to worry about them coming after this. So we're going to go ahead and put the 216, because over 423, that's about a half. And then you now have, at this point in time, you have 10 13s, 14 16s, and 10 11s. 10 13s is a half, bigger than a half, and it's 3 away from being a whole, because 13 13ths would be a whole. 14 16ths is only 2 away from being a whole, and it reduces to 7/8, which makes it only 1 away from being a whole. So it's going to be bigger than 10 13ths, because that's 3 away from being a whole, and 14 16ths is 2 away from being a whole, and 16ths are smaller than 13ths. So 10 thirteenths is 3 away. 13ths are bigger than 2 sixteenths, which is how far away this one. These are smaller, so it's going to be closer. So that means 10 thirteenths is smaller than 14 sixteenths. The next thing you want to know, how's 14 sixteenths and 10 elevenths work? Well, this is where I reduced it to 7 eighths. 7 eighths is only 1 away from a whole, and 10 elevenths is only 1 away from a whole. 11ths are smaller than eighths, so therefore it's closer to 1. So 10 elevenths is closer to 1 than 4 sixteenths. And again, I reduced 4 sixteenths to 7 eighths. This is only 1 away from a whole. 10 elevenths is 1 away from a whole as well. 11ths are smaller than eighths, so that means that the 10 elevenths is going to be a smaller distance from 1 than the eighths. And that's benchmarking. Here's another benchmarking one I want you to look at. 5 nines or 7 ninths. These have the same denominators, so the same piece sizes, so whatever you have more of is the bigger number. This was easy. 7 is bigger than 5. You have more ninths here than you do there, so 7 ninths is greater than 5 ninths, which means it's closer to 1. 4/5 or 8 ninths. This is 1 away from the whole. 8 ninths is just 1 away from 9 ninths. 4/5 is 1 away from 5/5. The bigger piece sizes are going to be the fifths, which means you're going to be farther away because the piece size is bigger, which means 8 ninths is bigger. So fifths are larger, so 8 ninths is bigger than 4/5. 2/3 or 3/7. This was comparing to a half. 2/3 is bigger than a half. 3/7 is going to be smaller than a half because half of 7 is 3.5. Half of 3 is 1.5. So this is bigger than a half. This is smaller than a half, so this has to be bigger than that. So I compared to a half. Okay, what is a fraction? It's a ratio of numbers part to whole. And I don't know if you looked this up, but to me, there's not a whole lot. I mean, I don't know how you would distinguish between a fraction and a rational number because they're kind of the same thing. But even a rational number is just the name of the type of number is pretty much the difference. That's what you call it. It doesn't really represent anything as much as it's a title. So if you're talking about rational numbers, you're just talking about what type of a number it is. Fractions actually describe the value of the number, and that's the difference. So, and it's a ratio of part to whole, all right? Can any number be used in the numerator? No, you can't divide by 0. And this was the one a lot of people missed. If a number is not a whole number, then it's a rational number. False. Irrational numbers are not whole or rational. Okay, so irrational numbers cannot be written as a fraction. So if it's not a whole number, it's not a rational number. And if it can't be written as a fraction, it's not a rational number. So that would include irrationals. Okay, we did these flag examples on the board. The only one I really wanted to point out was this one right here. Half is red, so I cut the diagonal and colored in half as red. And then for the 1/3 yellow, the 1/6 blue, it was easy to figure out how much a sixth is because I just cut it like that. And then you have 1, 2, 3, 4, 5, 6, and I colored in a 6. I just colored in what was left with the yellow for the 1/3. I don't even really care. If I have half and I have a 6, that by default means the yellow has to be the leftover. So that's an easier way probably to work that. Okay, for the trapezoid one, 3/5 again. 3 is the number that you have. This was your trapezoid, which was here, this much right here. Okay, there was your 3, so we have 1, 2, 3. And that means that 5/5 would be the whole, so you have to add one more of these triangles and another, so now you have 5/5. And then if you cut each of those in half, whoops, I forgot to cut this one in half, then you now have tenths. If the trapezoid from part A represents 6/5, so here you have 1, 2, 3, 4, 5. Okay, so this is the trapezoid. Sorry, here is the trapezoid right here. 6/5. So now you got to cut your trapezoid into 6 pieces, which here you see 1, 2, 3, 4, 5, 6. And then it says how large is the whole, which would be 5/5, which is the part I've shaded in, which I think most of you got that right. If I went too fast for this, just stop and go back. You guys have control over that. This was just yeah, this is the mental algorithms, which we'll do eventually, so I'm not going to worry about those right now.